the position of percentiles. So position of the percentiles, it simply represents the position, the percentage on the position of lower quartile, and then median, which is Q2, and then the upper quartile. So now let's start with the position of quartile 1, or let me use this word of percentile. Percentile. So now let's start with the percentile for Q1. So it means in this case, we're going to identify the position of the data for Q1, of which I believe you still remember it was at position 2, right? So then now it's 1, 2. Therefore, that 2 is our percentile that we have to substitute here. So it will be 2 divided by 100, and then we multiply by the number of elements we are given in this data set, of which I believe you can agree with me is at what? Is 7, the total number of elements that are given in this case. Therefore, 2 divided by 100 times 7, that will give us a percentage on position number 2 of this data that we have here. So let's see what value we have for this specific question. So we're going to have 2 divided by 100 multiplied by 7. So that is going to be at 14%. So that is our position of a percentile, which you can also write as 0.14. It's the same thing. And then let's go to a position of percentile for a median. So for median, we are going to count at the specific position of the median, of which is 1, 2, 3, is at position number 4. Therefore, we're going to have 4 divided by what? By 100, and then we multiply by the total number of data we are given in this case. So it's 4 over 100 multiplied by 7. And then that will give us 28%. So it's at 28%. And then the last one, position of Q3. The percentile for Q3 is at which position? I think we find it to be 56. So it's 1, 2, 3, 4, 5. It's at position number 6. So it's 6 over 100 multiplied by 7. So that will give you 6 divided by 100 multiplied by 7. And that will be at position number 42. It's at 42%. So, and this is how you calculate the percentile. But I will have to come with more examples so that you see how we do all these things. Because all which I've covered here, they are very, very important. They are converging to one point where you end up calculating the standard deviation and the variant of the data, which is not very fundamental, is very important. So I will want to use this time to explain that last part of finding the standard deviation and also finding the variant. Before I do that part, let me know if one of you knows how to find the standard deviation and how to find the variant. Is there anyone who knows how to find the two important aspect of this module? All right, let's quickly do that part in the remaining minutes so that you see how we find the standard deviation and the variant. I can tell you that part you will have to know how to do it without using a calculator. This time around is simple because you can also do it in your calculators, but I don't encourage you to do the standard deviation and the variant in your calculator only, because sometimes you may get it wrong from the calculator, then you must be able to do it manually. So this is how you do it manually. You draw a table. There is no shortcut here except using a calculator. So you must draw a table, of which in that table you are going to have the X values. So X values are all the values given in the data sense, whether they are in order or not in order, it doesn't matter. But let me use the one which with the data in order. So we're going to have 5 as the first data there. The second is 10, 21, 32, 48, and then we have 56 and 56 again. So this is the data we are given in this specific question. So on this data, we have to find the mean, of which the mean is represented by X bar, right? So we calculated the mean previously. Can any one of you remind me, how do we calculate the mean? We have done the mean in the previous calculation. How do we find the mean of the data set? Let's say we are having this data and we want to calculate the mean. How do we do it? Any idea?
Is it that formula you gave us?
Yes, we use that formula. So it's the one that will help us to get the mean. So that formula simply means that we have to add all these values and then divide by the total number of values. So it would be 5 plus 10 plus 21 plus 32 plus 48 plus 56 plus 56. And then when we get the answer, we divide that answer by the number of values given. I believe you can agree with me that we have 7 values here. So we have to divide by 7. So when we divide by 7, we will get a mean which is 32.6. So that value is supposed to write it everywhere on this data, because that is the mean for all the values that we have here in the board. So we have 32.6 as the mean for the data. So, and then on that mean, we then have to find the difference between the data and the mean. And then that difference, we must then square it like this. So some they find the difference and then square the difference at the same time here. So now you can see, I believe you all see that here we have xi, which is this data given, and xi is the what? Is the mean. So you subtract this with that. Don't start here. Start from this one, right? So that we also cater for. So we are going to say 5 minus 32.6, and then we square it. So I'm doing it in calculator so that you follow how to find this part of the standard deviation. Remember, the target of doing all these things is to find what is called the standard deviation. So it's 5 minus 32.6. 5 minus 32.6. And then after getting that value, you then square it. We're having a square here. So when you square that value, you will then obtain a value of 761.76. So we do the same on the second one. If we do the same on the second one, it will be 10 minus 32.6, and then you square it. That will give you 510.76. We do the same here. We subtract this and that, and then we square it. So it's going to be 21 minus 32.6 and then we square it. That will give you 134.56. Then we go to the next one, is 32 minus 32.6, and then we square it. That will give us 0.36. And then the next one is 48 minus 32.6, and then we square it. That will give us 237.16. And then for 56 minus 32.6, and then we square it. That will give us 547.56, of which it will be the same with this other one. So let me just copy it down here because we're the same difference. So we are going to get the same thing. Are we together up to here?
Mm-hmm.
All right. Then after having that, we then sum up all these values here. We add all of them. So when we add all these values, we are going to get, let me add all of them, is 761.76 plus 510.76 plus 134.56 plus, what did I, let me verify that value. I don't agree with that one. It's 32.6. Oh yeah, it's correct. Because it's 0.4 squared, which is 0.36. All right, let me do calculations here. 134.56 plus 0.36 plus 237.16 plus 147.56 plus 547.56. So that will give us a total of 2,739.72. So this is the summation of all these values that we got there. So after getting that summation, then we are now closer in getting what is called the variant. So the variant, which is simply a sigma squared, this is simply a sigma squared. It will be equal to this value that we got down here, and we divide by the total number of values. So we got the value of 2,739.72. That value we must divide with the total number of data given there. It means it's divided by 7. So that will give us what is called a variant. So the variant is simply 2,739.72 divided by 7. That is equal to 391.39. So that is how we calculate a very important quantity. I will explain to you what is a variant. So a variant, this is how we calculate a variant that we have in this case. Then now, the king master of all these is what is called the standard deviation. So the standard deviation is simply a sigma. It's represented by sigma. So remember, the variant I said is sigma squared, right? And then the standard deviation I said is what? Is simply a sigma. That simply tells us that is the square root of the variant. This is simply as the square root of the variant. So therefore, that value we obtain as the variant, we have to square root it. So we're going to have square root of 391.39. So that will give us what is called the standard deviation. So let me see what is our standard deviation here. So our standard deviation is 19.78. And this is how we find the standard deviation. You cannot shortcut this process. if you want to get full marks, you must follow this procedure. You get the mean, you get the difference, and then you square it, you find the summation, and then from there, that summation you divide by 7 to be a variant. And then the standard deviation, it will be the root of the variant. So then our standard deviation is 19.78 for this specific data that we give you. So I believe you can see that we got to the answer of the standard deviation without using a lot of formulas here. But before we wrap up for today, I would like to give you a formula, a specific formula for calculating the standard deviation, of which instead of writing a word standard deviation, I will use a sigma notation. So now the standard deviation is given by the summation from I equal to 1 to n of xi minus x bar squared, all divided by n. And that will give me, and the root as well. So this must be under the root. That will be what is called the standard deviation, is the formula of the standard deviation. So I tried to summarize a lot of things for you here. We are still going to do a lot of questions tomorrow. I've been covered the scattered plot, the ogive graph, and other important things. So all those things I will explain to you tomorrow before we go to as many questions as possible. So I'll just touch here and there. So I explain what is left. We still have to do the ogive graph, the symmetric graph, and there are still most other important things which we have been covered. The least square regression, that is a very important method. So I'm going to take you through that method tomorrow, and the correlation coefficient. So I'll do all those things with you tomorrow. So, but today let's cover it up to here on the standard deviation. So I think it's enough for the day, unless if you have a question before we wrap up, you can ask me before we finish up with our lecture for the day. If you have a question. You are all okay. All right. So it's fine. Let's meet tomorrow, and then I will continue with lesson of studies. So have a good night and goodbye.